Hi friends, welcome to this session. So in this session, we are going to see how to find the partial fractions for the given proper fraction. So basically, proper fraction is a fraction in which degree of numerator is less than degree of denominator. And there are different forms of proper fractions. That means proper fraction with repeated factors in denominator and we can have proper fractions with unrepeated factors in the denominator, and third case is the case proper fractions with unfactorized quadratic expression. It means we are not able to factorize the quadratic expression. So these are the three cases of proper fractions. Now we are going to see how to find the partial fractions for each of the case of partial fraction. Firstly, we will see how to obtain partial fractions for the given proper fraction with unrepeated factors in the denominator. That means if f of x is equals to p of x by q of x is a proper fraction where q of x, which is nothing but the denominator, are unrepeated. That means it has unrepeated factors or unrepeated poles. So let us see with an example. F of x is equals to 2x square plus 9x minus 11 by x plus 1 into x minus 2 into x plus 3. So this is the case where the denominator has unrepeated factors. First of all, check whether this fraction is a proper fraction or not. Degree of numerator is 2 and degree of denominator is 3. That means degree of numerator is less than degree of denominator. So it is a proper fraction. Now what we have to do is we need to split the given fraction, that is 2x square plus 9x minus 11 by x plus 1 into x minus 2 into x plus 3 into individual partial fractions with numerators as unknown values and denominators as each unrepeated factor. So a by x plus 1 plus b by x minus 2 plus c by x plus 3. So these are the partial fractions. Now we need to find the values of a, b and c in order to obtain the partial fractions for this given fraction. Now expand this expression on the right side. That means add the individual partial fractions. That means a into x minus 2 into x plus 3 plus b into x plus 1 into x plus 3 plus c into x plus 1 into x minus 2 divided by x plus 1 into x minus 2 into x plus 3. If you observe on both sides, the denominator are same. So cancel out the denominator on both sides. So now we are left with numerators on both sides. And now we need to substitute the roots of the denominator, that is the values when the denominator is equated to 0 are called as roots of the denominator. So by equating this denominator equal to 0, we get the values or roots as x equals to minus 1, 2 and minus 3. So these are the roots of the denominator. Now we need to substitute these roots of the denominator in the obtained expression, that is 2x square plus 9x minus 11 equals to a into x minus 2 into x plus 3 plus b into x plus 1 into x plus 3 plus c into x plus 1 into x minus 2. I will rewrite this for your clarity. So we are left with the expression 2x square plus 9x minus 11 is equals to a into x minus 2 into x plus 3 plus b into x plus 1 into x plus 3 plus c into x plus 1 into x minus 2. So we are left with this expression. Now we need to substitute the values x equals to minus 1, x equal to 2 and x equal to minus 3. First we will see for x equals to minus 1. So by substituting this x equal to minus 1 in this above equation, we will get as 2 minus 9 minus 11 is equals to a into minus 3 into 2, which is equals to minus 18 is equals to minus 6a. This implies a is equals to 3. So we got the value of a. Now substitute the next root value, that is x equals to 2 in the above expression. This implies 8 plus 18 minus 11 is equals to b into 3 into 5. This implies 15 is equals to 15b. This implies we get the value of b as 1. Now substitute the next root, which is x is equals to minus 3 in the above expression. So by substituting minus 3, we get 18 minus 27 minus 11 is equals to c into minus 2 into minus 5. This implies minus 20 is equals to 10c. This implies c is equals to minus 2. So we got the values a, b and c. Now by substituting these values in the partial fractions, we can get the partial fractions of 2x square plus 9x minus 11 by x plus 1 into x minus 2 into x plus 3 as a is 3, so 3 by x plus 1 plus 1 by x minus 2 minus 2 by x plus 3. So in this way we can obtain the partial fractions for the given proper fraction, and this is the case where the proper fraction denominator has unrepeated factors. Now we will see the case 2, that is partial fraction expansion for proper fraction with denominator has repeated factors or repeated roots or poles. That is, if f of x is equals to p of x by q of x, where q of x are repeated. So now we are going to see how to obtain the partial fractions for this case with an example. F of x is equals to x cube plus 3x square plus 4x plus 6 by x plus 1 into x plus 2 into x plus 3 whole square. Here x plus 3 is repeated 2 times. And first of all, find whether this fraction is a proper fraction or not. So degree of numerator is 3 and degree of denominator is 4. So degree of numerator is less than degree of denominator. This implies it is a proper fraction. Now we will split this given proper fraction into partial fractions. X plus 2 into x plus 3 whole square is equals to a by x plus 1 plus b by x plus 2 plus c by x plus 3 plus d by x plus 3 whole square. So in this way we need to split the partial fractions when the denominator has repeated factors. And now we need to add the partial fractions on the right side. So we'll get a into x plus 2 into x plus 3 whole square plus b into x plus 1 into x plus 3 whole square plus c into x plus 1 into x plus 2 into x plus 3 plus d into x plus 1 into x plus 2. As the denominators will get cancelled on both sides, so we will be left with the equation x cube plus 3x square plus 4x plus 6 is equals to this one. Now in this we need to substitute the roots of the denominator. So by equating the denominator equals to 0, we will get the roots as minus 1 minus 2 and minus 3. So now we need to substitute these roots in this expression and find the unknown values. So first we will substitute x is equals to minus 1. So for x equals to minus 1, we get minus 1 plus 3 minus 4 plus 6 is equals to a into 1 into 2 square. This implies 4 is equals to 4a. This implies a is equals to 1. And substitute next root, that is x is equals to minus 2. So minus 8 plus 12 minus 8 plus 6 is equals to b into minus 1 into 1 whole square. This implies 2 is equals to minus b. This implies b is equals to minus 2. And substitute next root, that is x is equals to minus 3. For x equals to minus 3, we get minus 27 plus 27 minus 12 plus 6 is equals to d into minus 2 into minus 1. This implies minus 6 is equals to 2d. This implies we get the value of d as minus 3. So, by substituting the roots of the denominator, we got the values a, b and d. But we need to know the value of c. For that, what we have to do is, we need to expand the expression on right side. So, we need to expand this expression and collect the common terms and compare the coefficients of similar powers of x on both sides. So, firstly we will expand that expression. So, x cube plus 3x square plus 4x plus 6 is equals to a into x plus 2 into x plus 3 whole square plus b into x plus 1 into x plus 3 whole square plus c into x plus 1 into x plus 2 into x plus 3 plus d into x plus 1 into x plus 2. So, after expanding all these terms and collecting the common terms, we will get the evaluated expression on the right side as x cube into a plus b plus c plus x square into 8a plus 7b plus 6c plus d plus x into 21a plus 15b plus 11c plus 3d plus 18a plus 9b plus 6c plus 2d. So, after evaluating the expression on the right side and collecting the common terms we got the expression on the right side as this. Now, what we have to do is, we need to equate the coefficients of similar powers of x on both sides. That means equate the coefficients of x cube on both sides, equate the coefficients of x square on both sides, equate the coefficients of x on both sides, and equate constant terms on both sides. So by doing like this, we get 1 is equals to a plus b plus c. This we got by equating the coefficients of x cube. This is termed as equation 1. And by equating the coefficients of x square, we get 3 equals to 8a plus 7b plus 6c plus d as second equation. And by equating the coefficient of x on both sides, we get 4 equals to 21a plus 15b plus 11c plus 3d as third equation. And by equating the constants on both sides, we get as 6 is equals to 18a plus 9b plus 6c plus 2d. So these are the equations which we obtained by equating the coefficients of similar powers of x on both sides. And already we know the values a, b and d. We need to find the value of c. So in equation 1, we will substitute the values of a and b and we will obtain the value of c. So a equals to 1, b equals to minus 2. So 1 is equals to 1 plus minus 2 plus c. This implies c is equals to 2. So now we got all the values of a, b, c and d. Now we can express the given single proper fraction as multiple simpler partial fractions. X plus 1 into x plus 2 into x plus 3 whole square is equals to 1 by x plus 1 minus 2 by x plus 2 plus 2 by x plus 3 minus 3 by x plus 3 whole square. So in this way we can obtain the partial fractions for the given proper fraction in which the denominator has repeated factors.